Hello, I'm James Ingram for AutoControls.org. Welcome to video number 668. In this two-part video, we'll demonstrate using a Z-Stuff DZ-1012 block signal detector and a Z-Stuff relay to keep two trains on the same track separated. We're using O gauge, but this method should work for any gauge, 2-rail or 3-rail. This is one of the simplest ways to control trains that are not DCC. All we have to do is make one insulated block section in the track. For this 3-rail system, we're using the center rail. There's no reed switches nor magnets required. We're essentially using the block signal detector's time delay to simulate the location of what would be the second reed switch if we were using reed switches. There's actually two different ways we can wire this block signal and relay up. In part one of this video, which I'll call the delay from the front system, and this is the recommended way, I think, to do it the most versatile, we'll wire the block to the normally closed terminal of the relay. And the logic is that when the front train goes through the block, it sets the block red, turns off the power in the block so that a train following too closely is delayed for however long the time delay is set for. Now in part two, we'll use a different logic, and I'll call it release from the rear, and this sort of works the same way that the insulated rail system works, which was covered in the previous video 667. In part two, we'll wire the block to the normally open terminal of the relay so that a train coming into the block will be stopped, and it'll have to sit there and wait until another train following from the rear crosses the detector, which will close the contacts on the relay and release the first train. We think the delay from the front method, as shown in this first part of the video, is the most versatile. You get different, there's basically three reasons. You get different effects without having to move the detector. You just adjust the time delay, and it works fine with just one train. You don't need to change anything when you're running just one train. And thirdly, the red-green signal is operating right at the end of the block where the trains stop. Now keep in mind, these systems, both of them are one direction only, and you can't really run in reverse. If you're going to run trains in reverse, you have to jumper across the block. Now in the end of the second video, what we're calling part 2B, there's a section called related videos, and in that section we copied parts of about 6 different videos, including scenes from the APS electric eye control, which operated very similar to how the Z-Stuff system works. Another video using reed switches, and also another video using the railroad concept station master. In other words, that part 2B at the end of the second video shows some alternate ways to do this two-train operation that'll work on 3-rail systems or 2-rail systems. Thanks for watching. This is a Z-Stuff DZ-1012 block signal detector and a Z-Stuff DZ-1008 relay controlling 2 O gauge trains running on the same track. The logic is when one train passes a detector, which you see over there on the right in the rear, it'll go past that detector and it'll set the block signal to red, which it did now. Right there, it sent to red, and that made that block behind the train dead, which will stop that yellow train that's trying to catch up with it. Now there's about a 10-second time delay, and when that signal changes from back to green, which it just did, it will re-energize the block, and that yellow train can start up. This is one of the simplest methods of controlling two trains. It has minimal wiring. When you're only running one train and has no effect at all, the train just goes through the block and sets it red behind it, but there's no second train nothing happens till the block signal just times out again and goes green. And this system should work with any gauge, be it 2-rail or 3-rail, and it can switch AC, DC, or DCC current. The relay points are isolated from the rest of the system, so they can switch any current. The DZ-1012 detector has a adjustable time delay from 1 second to 60 seconds. We've got it set here for about, I think, 10 seconds or so, which kind of keeps these trains spaced a comfortable distance. And the block is on the right. If you see, notice there's a couple of note cards. There's one here in the front, and then further back there's a second red note card. Those two note cards denote the beginning and the end of the block section, which is simply a section where the center rail has been cut, and the relay switches power on and off to that center rail to stop and start trains. The outer rails are undisturbed. They're continuous the whole way around the loop. Now the approximate go point is over approximately here where that green note card is. You notice when that engine gets there, the block signal changed from red to green. It's like having a virtual reed switch in the track. If you were using magnets and reed switches, if you consider an engine with a magnet went over a reed switch at this point, it would switch the relay to green. Well, there's no magnets, no reed switches. We're using timing to sort of make a virtual reed switch. Now, if we speed these trains up or slow them down, it does move that point effectively. There's the worst case where you have one train right behind another train almost pushing it, but you'll see what happens when the passenger train gets into the block. It'll go in front of the detector. The detector will cause the relay to switch the block to red, which will stop that yellow train from chasing it. The block detector just went red. You can see that yellow train stop. Now it's executing a 10-second time delay, which allows that passenger train to get out ahead and regain its spacing. So what this system is doing is continually respacing trains. Anytime a train starts to get too close to another train, the block detector will stop the train in the rear, which is what you just saw. Now we'll speed the trains up a little bit, and you can see it'll change the spacing a little bit. Now we're running a little bit faster, and that go point moved just a little bit because the engines are running faster now, I believe, but it still can keep the spacing pretty well. You may notice the passenger train, which is coming into the block now, that goes further up into the block than the freight train, and the reason it does that is those cars, well, it went through it was green, but those lighted passenger cars have double rollers, and they conduct power into the stop block. We'll do our same separation demonstration again, just with the trains running at a slightly faster speed. You can see the yellow trains essentially pushing the passenger train into the block. When that passenger train goes past the detector, it'll change the block to red, which will cut the power off in the block section, thus stopping that freight train, thus allowing the passenger train to regain its spacing. Now I've changed the timing on this, that is to say I've changed the time delay on the Z-Stuff detector from 10 seconds to about 23 seconds, so that effectively moves our go point further downstream. You can see there's a note card over here now, and that note card is approximately where the block changes from red to green, so our virtual release point has been moved downstream due to increasing the time. It used to be over here when we had the time delay set at 10 seconds, but when we increased the time delay, it effectively moved our release point downstream. Now you can see both trains are stopping at this point. The passenger train stopping and the freight train is also stopping. You can see the freight train stops right just as it enters the block. But if you watch the passenger train when it enters the block, you'll see it'll go a little bit further. And again, that's because those lighted passenger cars, the two front cars in that train, have double rollers on the back, and they tend to conduct power into the stop block. And that, combined with the momentum of those engines, they have quite a bit of momentum. It tends to make them roll into the block a little bit further. Now we'll speed this up, and when we speed that up, speed the trains up, that'll move that release point even further downstream. If I increase the speed too much, they'll almost catch each other. We'll see what happens. Now you can maybe see that passenger train. It got a little bit past the green note card, someplace right around up here before the block went to green. And that yellow one will be even a little bit further because it moves a little bit faster than the passenger train. You can see the yellow one's almost on the corner there before the block goes to green. So this effect of making a longer delay has the effect of moving the trains downstream before it goes green. You probably wouldn't want to use quite this. This is probably I guess we could say this is the extreme limit. You wouldn't really want to run them with this time delay. Probably the 10 seconds or so like we started out in the first demonstration is a good compromise. But this is just to show you can vary the speeds of the trains and vary the delay time setting in the block detector to get different effects. We should still be able to do our same demonstration of a train pushing a train and watching the blocks separate them as before. There, the block went to red and the yellow engine with the freight train stopped, and it just having the longer time delay, you can see, gives them a lot more separation. There we can see the block changes to green, and we're back to steady state operation, so to speak. Now here's a bigger speed mismatch between two engines. If we put the 280 on the passenger train, the 280 is not even supposed to go around 27-inch radius, 27-inch diameter track. These two loops, the ends closest to the camera are 027 track, which means it's a 27-inch diameter track, and that 280 says it's a 31-inch minimum radius, so it bogs down quite a bit on these tight curves, and thus it's going quite a bit slower than that yellow dockside engine. And I had to turn the speed up enough to keep it moving through the corners. So you can see what's happening. The dockside engine tends to rapidly catch up with the passenger train, but nevertheless, as long as we can get the passenger train through the block before the dockside engine catches up with it, the block control will regain the spacing between the trains. See, the passenger train's getting someplace over in the vicinity of over here where that green note card is before the block turns to green and releases the yellow engine. We should be able to perform our same experiment as before, a train chasing a train, and watch the block signal separate them, except we got a derailment. One thing you'd like when you're running two trains on the same track and they're alternately stopping and starting is for your transformer to maintain a relatively constant voltage level so the speeds stay the same. This is an old Lionel 90 watt type 1044 transformer we're using here, and it does a pretty good job. What we've done is hooked up a voltmeter to the voltmeter's hooked up to the terminals coming from the transformer to the track, so we can monitor the voltage as these trains stop and start. You see it's about 10.8 volts with both trains running. Now that yellow one went in the block and stopped, so the voltage went up just a little bit. There it's showing about 11.2. Now you can see when both trains started up, it went down to 10.8. So it's going up and down a little bit, but it's doing a pretty good job of holding the voltage constant. If you can't keep the voltage relatively constant, the problem you have is that when one train stops, the other one will speed way up. And then when they both start up, they'll both slow down, which is less desirable. So this transformer's doing pretty good. It's holding the voltage between about 10.7 or 10.8, maybe 11.2 volts. Here's our layout view from a different angle. You can see it's a 027 track, courtesy of the Milton Model Train Museum. I believe those are 042 curves on that end and 027 curves on this end to get it to fit on this 5x9 ping pong table. And then over here where these red note cards are, we have our stop block, and down at the end is the detector. The block starts right at here. The trains are coming from that direction around here, and you can see maybe I just crudely cut a gap in this center rail with a Dremel tool. That's the beginning of the block, and then if we follow it down here where the red note card ends, right about here, you can see there's another crude gap I cut in the center rail with a Dremel tool to make the end of the block. So that's the stop block, and here's our detector. And I should say, here's our block detector relay assembly. I made a crude assembly out of this and put it on a piece of wood and wired it all up. I'm sure most people can make a neater job of this than I did. I'm not that good at assembling things, but we basically are using, it has two input contacts here. You can see down there on the right where it's yellow, it says power. We hook two wires into that for power wires, and then where my thumb is here on the left, there's a common and a normally closed terminal. These two terminals here go out to the track. One comes from the main line and one goes to the stop block, and all they do is connect and disconnect the power going into the stop block. So basically, viewing this thing as an assembly, you've got two wires coming in here for input power to power the unit, and two wires coming out here, the output that turns on or turns off the stop block. Now we've got this unit hooked back up again, and this is our DZ-1012 block signal detector here, and this is our DZ-1008 relay, and these are wired together per the Z stuff instructions. And here's the Z stuff instructions that tell how to do that. And I'll go over this again later when I show the wiring diagram. But this thing is I believe has an LED that sends out a signal, and then there's a detector, and I think it basically bounces it off the cars. I'm not exactly sure how it works, but it detects when there's a car next to it. If like we roll a car here, it'll pick up, and you see that went from green to red, and you can see it cut the power off in the block. It turned off the lights in that passenger car. Now if I clear the detector like a train, the end of a train exiting the block, in about 4 seconds that'll go back to green. It'll turn the power back on. And again, these are our two outputs. This wire is coming in off the main line, and this wire here is going to the stop block, and all this relay is doing is connecting these two terminals together when it's green, and when it's triggered to red, it opens those two terminals, so there's no power flowing from this one to that one, which cuts off the stop block. This block detector is supposed to detect cars on the track next to the block, like this track here. Again, when that detector is blocked, it goes to red, but it's not supposed to detect trains on adjacent tracks. If we roll this car up here, you can see it doesn't detect that car. And I think how they accomplish is, I think they send that signal actually up on an angle, because if I bring my hand in from up above, I can actually set it to red over here where this car is, but I have to be up in the air. So I think the way I'm not sure of this, but I think the way they do is work that as sending that signal out on an angle. So the train has to be close to the detector before the detector will sense the train. But the idea, again, which you've already seen in the demonstrations, if you have two trains and one train is pushing another train, say this caboose is the end of the one train and this passenger car is the train that's following that train, when the first train sets it to red, any train that's behind, the power will go off. You can see the lights went off, and this train will leave the block and get part way around the layout, and when the detector resets again, when the block signal resets again to green, then you can see the lights came on and the power comes back on in the block. So this train can now leave. In this, I've got this detector set right now for 4 seconds. If I block it, it stays red for about 4 seconds, and then it goes back to green. And that's adjustable from 1 second to 60 seconds on the stock units, and you can order them with a longer delay also. Now we'll try to demonstrate setting the time delay on the detector. The Z stuff instructions here for this unit, they call it, what it tells you to do is turn the power off, and while the power is turned off, you hold the yellow wire, which I've got in my thumb here, to the white wire, which is part of the terminal block. So if I just touch this yellow wire to this screw that the white wire is hooked up, I've made that connection. And when the yellow wire is connected to the white wire, they say to turn the power on, and the light will blink, I believe it's a red light, will blink once per second, and you count how many blinks you want, and that'll set the time delay and the number of seconds. So I'm going to try to set it for 3 seconds. So we'll try to go for 3 blinks when I turn the power on. Here we go. 1, 2, 3. So there was 3 blinks, and I yanked the wire away. So now if we activate this detector, we get about a 3-second delay. Now we'll do the same thing again. Turn the power off, and we'll shoot for a 6-second delay. 1, 2, 3, 4, 5, 6. So there was 6 blinks before I pulled this yellow wire away from the white wire. So there's 1, 2, 3, 4, 5, 6. That gave us about 6 seconds. And now we'll do the same thing, and we'll try for 10 seconds. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now let's test it. 2, 3, 4, 5, 6, 7, 8, 9, 10. It went back to green. So we can adjust this timing all the way up to 60 seconds on the stock unit. The minimum, I think, is 1 second. The maximum is 60 seconds, and I believe they can build custom units with longer delays. I have a modified one they built for me at an extra charge. It's supposed to go up to 5 minutes. I haven't tested it yet, but that was the way it was built. Now, one other thing you can do with this detector, and we're not using it for this video, but it's handy to know that it has that capability. You can sort of use it as a timer. The Z stuff instructions tell you that if you connect the yellow wire, again the one I have in my hand that we were using to set the timing, if you connect this yellow wire to the black wire, the common wire, it will trigger this thing for whatever time delay it's set to without any train going in front of the detector. So this second terminal right here, you may or may not be able to see there's black wires connected to that. If I bring this yellow wire down to the black wire and touch it, you can see it goes into the red state, and it'll go for its amount of time. I reset the time to 5 seconds, but it goes for 5 seconds. And again, we're not using this feature for this demonstration, but if you were, what this capability allows you to do is hook a push button up. If you hooked a push button up between this yellow wire I've got in my hand and this terminal with the black wire, you could use that to have a push button trigger this thing to close a circuit for, or open a circuit or close a circuit for a set period of time, because we do have a normally, I didn't talk about it, but over here we've got the other wire that's a normally open contact. So if you wired up to the normally open contact, you could start up like a merry-go-round or any kind of a display for anywhere from 1 to 60 seconds, having it controlled by a push button. In other words, when somebody pushed a push button, it would connect these two wires, trigger the block signal time delay for whatever amount of seconds it was set for, and it would run that display. And again, this one has capabilities of 1 second to 60 seconds. The custom one they made for me that goes out to 5 minutes, I figured I could use it to run like a train for 5 minutes on a push button, and the whole display would stop after 5 minutes. It would time out. This would be like a public display. If somebody came along and pushed the push button, it would start, and when they left, it would all stop after 5 minutes. One more comment regarding operating in this block with passenger cars. Note where that yellow engine stopped, just inside the block. The block, is, again, recall, is from about where that red note card is, where the straight track starts. That's where the block starts, up to here. But now watch this passenger train when it comes in. You'll see those first two cars, which have the dual rollers on. They tend to push the engine further into the block because they conduct power across the block while the engine's coming in, and combined with the engine's momentum, it tends to roll quite a bit further. So now when the freight train comes in, you'll see that engine doesn't roll nearly as far into the block because there's no lighted passenger cars behind it bringing power into the block. I've got the time delay set, I think, to 23 seconds, so that makes them both stop in the block for a while. Note you can experiment with these time delays to get different effects. Now again, watch the passenger train when it comes in the block. You'll see it rolls quite a bit further because those first two lighted cars have the dual rollers, and that's causing it to come further into the block. Here you can see those passenger cars. This is the second car, but you can see it has the dual rollers, and when those rollers are the time that those rollers are going over the gap in the track, they conduct power for that whole distance, and that's what tends to make that passenger train pull further up into the block. Now this is the third car, and notice it's got only one roller. These don't cause any problem. That's why I've got this car back third. Normally, this is the combine. Normally I'd run that right behind the engine to attempt to be more prototypical, as if that's a worry on 027 layouts, but because of the way these rollers work, I put this one back in the rear so so this train wouldn't pull up any further than it already does. Here's another variation on the way we can handle this block. What we've done here, using it from another project, we've wired in a 15 ohm 25 watt rheostat that was left over from a previous project, but we've just wired that across the two output terminals from the relay. The common wire, a wire from the common terminal goes down to the rheostat, and then the other wire comes from the rheostat back up to the output terminal to the stop block. And so this rheostat is essentially mounted in parallel with the relay contacts. And how this works out, when the block goes to red and it opens these contacts, instead of the block being totally dead, because this rheostat is wired in parallel, current can flow through the rheostat, so there'll be current going to the stop block even when the block is red, but it'll be a reduced voltage. And the net result is that train coming into the stop block now it'll be a slowdown block. So instead of making a complete stop, it'll just slow down, and we'll demonstrate that in a minute. There comes the passenger train through the block, and the block should be green, but you can see that freight train's trying to catch it. Now the block should have gone to red. You can see that the freight train is slowing down, so it's slowing down through the block, but it's not making a complete stop. So basically what we did is we increased the separation between the trains by just slowing the faster train down. This is just an alternate way of doing it, and you could make this block longer for this purposes. And ideally it should be on a straight track, not a curve, but with the size of this layout, don't have any choice. Now here again you can see the freight train is coming into the block, and you can maybe see the headlight dims and it slows down, so it's kind of creeping through the block. But this way we're getting spacing, we're increasing the spacing between the slower train and the fast train, but we're not stopping the fast train completely, we're just slowing it down. This has been done by other people before on other layouts, so we're just setting it up and demonstrating it here. And again, here's our fast train coming into the block, and the block is red, so it's slowing that freight train down. I think I've got the delay time on the block detector here set for around 12 seconds. These are things you can experiment with. You can experiment. In this case, you can experiment with the rheostat setting and also the delay time. I adjusted the rheostat so it doesn't stop completely, but it just slows that yellow train down. If you turn the rheostat up too much, then your engine loses speed completely. But I've just got it. You can see I've just got it creeping. But you can vary that rheostat. Right now it's kind of almost in the middle. We'll let this cycle one more time, but it's very easy to convert just one way or the other, because if I loosen these screws and pull these two wires down here away, it goes back to being a complete stop block. Like I say, we're just putting the rheostat in parallel with the relay. And again, there's our yellow engine creeping through the stop block at reduced speed. And then by the time the slower passenger train gets around to the stop block, it's timed out and gone to green. I should say by the time it gets around to the block detector, it's timed out and gone to green. So you notice the passenger train isn't being slowed down, just the faster train. Here's these two block detectors. The older DZ-1011 is the one on the left here. That's the one with the fixed time delay. I think that's been around since maybe approximately 2001 or so. And that's like I say, it has a fixed 1 second time delay. And then the newer DZ-1012 is on the right here, and I think that one just came out about 2017. That's the one with the variable time delay. This one's set for about, I think, 8.6 or 8 seconds. Takes a little longer to time out. In the stock form, these go from, I think, 1 to 60 seconds, and this is actually a custom one. I think it's supposed to go up to 5 minutes. They're built a little differently. The DZ-1011 has a complete body around it. The newer DZ, that's the one on the left here. The newer DZ-1012 kind of has a circuit board hanging out the bottom. I guess they simplified the design a little bit by doing that. Notice the newer one on the right, the 1012, is lower than the older one. I've been able to get this older DZ-1011 on the left to work with HO trains. It's really they claim it's designed for S gauge and O gauge, but it will work for my HO running on Cauto track. The only thing I notice, if a flat car goes by, it misses the flat car because of the height, but this one's even lower, so this one should work on HO trains just fine, as well as S gauge and O gauge and whatever size. Here's this DZ-1012 unit that I assembled into a kind of crude little assembly. The DZ-1012 detector is here, and then the DZ-1008 relay is here, and then I have a terminal block so I can wire it to the layout. These two wires up here, that's AC power coming in from my power pack, which is over here. And in these two wires, these are what go out to the stop block. This is the common coming in here, and the normally closed terminal that's here. So as this thing is sitting here now, it's in the green state, and if it was hooked up to power, if it's not, but if it was hooked, it's hooked up to an ohm meter right now, but if it was hooked up to the track, it would be delivering power to the stop block. And I've got this ohm meter over here set on the ohm setting, as you can see, and it's indicating 0, which it should. That means it's sending power through these two terminals. Now if we set it to red, you can see it goes real high. It climbs and it climbs. It's like reading a real high number of ohms, which means a real high resistance, which essentially is an open circuit, which means the power would be cut off to the stop block. So if we let it go back to green, you can see that drops to 0 when it's sending power through to the stop block. So this is just hooking it up to an ohm meter is a good way to check that it's doing what it's supposed to be doing before you start wiring it to the layout and testing it with trains. And incidentally, I had to switch the normally closed and the normally open wires. I think that's the white and the gray. I had to switch them from what the Z stuff drawing said to get it working properly. And I checked with Z stuff, and they said that depending on what unit is driving the relay, you might have to switch those wires. We said earlier this block signal detector could be used with a single train with no modifications needed. And here's just to emphasize that point, we just got one of the trains running on the layout. You see the block signal is green as the engine approaches it, and just like in the previous demos, it went to red as that engine went through. Now if there was a train following this train, as in the previous demos, that red signal would stop the following train. But since there is no following train, it just times out and goes back to green. So this thing is essentially almost invisible in your layout when you're running a single train, other than the fact that you're still getting the red-green operation with the signal light, but it doesn't cause any problems with your layout, and that's what's nice. When you want to put the second train on, you just put the second train on and you don't have to change anything. But when you want to run just one train, like we're doing now, you can do that, and everything works just fine with no special preparations needed. We can also set the time delay longer than it takes a train to get around the loop to have a station stop. I've set this thing for 45 blinks, which seems to give a time of around 39 seconds. It takes that train about 28 seconds to go around the loop until it reaches the back of the stop block, and you see the block is still red. Now when that train comes in there, it's going to stop. It's going to take approximately 11 seconds for that thing to time out. So we've got basically an 11-second station stop. Now you can see the block went back to green and this train started up automatically. Now it changed back to red. And again, we're going around the loop, and this should be around 28 seconds until it gets around to the block. Now I have about an 11 second stop at the station, if you imagine a station sitting there on the right side of the track. There we go. Do one more loop. There we're 28 seconds when we came into the block. That'll time out to about 39 or so, I think. Yeah, the block went back to green. So as long as your if your main line is too long, say it takes a train a minute to get around the loop, then this system won't work because it'll be timed out before the train gets there. But if you got a smaller loop like this loop, where you can set the block to be read for long enough time that it's still read when the train gets back to the station like it did now, then you can have a station stop. And all you have to do is just, like I say, modify the timing on the block, change it from like 10 seconds to 13 seconds, what we were using for 2-train operation, increase it up to about 39 seconds or all the way out to 50. I set this for 60 blinks, and I think I measured close to 50 seconds, so it may not go all the way to 60 seconds, but it goes pretty long. The rest of this Part 1 goes over the wiring diagrams used for Part 1. Please note that Part 2 has its own wiring diagram discussion for the hookup used in Part 2. If you go to the web page at AutoControls.WordPress.com, which is part of the AutoControls.org website, you should see a page that looks similar to this. In the top video is the insulated rail method 667. This video we're talking about now is video 668 using the Z-Stuff detector. So if we click on this link for video 668, that should take us to that web page. There it goes, video 668. And there'll be links to the video here when it's completed at the top. And then scrolling down this page, you should find some of the same images that are on the video. There's the photo. Here's figure 1, the connection. Figure 2, which is the main drawing hooking up the DZ-1012 to the track. And then another photo and drawing showing how to hook up the rheostat. And if you click on any of these, let's go back to figure 2. If you click on any of these, it should open it in a larger window so you can see it bigger. Here's the drawing for hooking up the DZ-1011 and the DZ-1012 block signal detectors to the DZ-1008 relay. On the left is the 1011 and on the right is the newer 1012. Now this drawing here, this sketch is copied from the DZ-1011 instruction sheet. So I basically just took what was on the Z-Stuff drawing and redrew it a little bit, which is what you see up here. Now for the DZ-1012, they don't have a drawing. What they have is some written instructions, and what I've done is circle those with this magenta colored box. And this tells you in words how to hook this thing up, and that results in this sketch here, how to hook the block signal detector up to the relay. And I verified this with Z-Stuff. I wasn't sure I was interpreting the words properly, but I verified it with Z-Stuff as being correct. And the thing to note is they don't hook up quite the same. With the 1012, the red of the block signal goes to the red of the relay, and the black of the block signal connects to the black of the relay, and then the white, which is output, connects to the green of the relay. And it's a little bit different for the DZ-1011, but if you follow these instructions, it should be correct. And one thing to note, the DZ-1012 is preferred over the DZ-1011 for these automatic control applications, and the DZ-1011 can be only used for method 2, not method 1, and hopefully the video will explain all that. Here's figure 2, which is our wiring for part 1 of the video using the DZ-1012 block signal. And this is what we call delay from the front, where a train in the block will stop. The block will cause a train following from the rear to be stopped. So this train going through the block delays the train in the rear. That's what we're referring to as delay from the front. That's the logic. When this engine goes past the detector will set the block to red. This is the stop block here, the red line. It'll set the block to red, and this train will be stopped. And whatever the amount of time delay you use, and I show I call a virtual release point over here. When this engine gets over here, the delay time will expire. The block will change from red back to green, and this engine that was being held up can start up. So basically what you're doing is establishing spacing between the trains each time they go around the loop. And if you have a bigger loop and engines that run kind of the same speed, it can actually put more than 2 engines on this. And there's, in the related videos section, we'll show an older G-scale video that actually shows, I think, 4 or 5 trains running on the same track using the same type of a system. This figure 2A is basically the same schematic that we had from figure 1, except we've added the hookup to the track in a schematic form. Over here in figure 2B is basically the same drawing, except it shows terminal blocks. I'm kind of old-fashioned and klutzy with wiring. I'd like to hook things up to terminal blocks when I can. And you can see the fixed power from the power pack is to the detector, and the relay is coming in over here on the red and black wires. And in the track power, the track power from the power pack is going out to the track on these yellow and black wires. And in the relay is picking up power from the track and going in through the relay and back to the track. And if you follow these wires here, this is all pretty simple logic. You can look at this like water flowing through a garden hose. If you consider this block signal detector in the relay to be an assembly, you can draw a dotted line around it like I did here. Consider that an assembly, and it just has 2 wires going into it for power and 2 wires coming out of it for the controlling the track. But at any rate, this yellow wire here is basically just a jumper to get the power around the stop block. Again, the stop block is in red. Incidentally, our outer rails are uninterrupted. Those would be the common rails. The center rail, which is normally wired as the plus rail, that's the one we're working with. So what we do is we take this uninterrupted power. The yellow is uninterrupted. That color is what that means. We take this yellow uninterrupted power, and again, just consider it to be water flowing through a garden hose to figure out how it works. Our current goes up this yellow wire into the relay on the blue common wire, and we're going to use the normally closed output for this method 1 here. And you can see the relay will normally be in the closed position, or I should say this when it's in the closed position for this wire, the power will come in and go out the white wire and down to the stop block. Now, if a train goes past a detector, so that the block signal changes from green to red. The relay contacts will essentially swing from this position shown here. They'll swing up here to power the normally open wire, but that's not connected, so it's not going anywhere. And the effect it'll have is when this contact swings away from the white wire terminal 6 and goes up and powers terminal 4, terminal 6 here will be depowered, which means the stop block won't be getting any power. And then when the relay times out, when the time delay on the block detector times out, the relay contact will swing back to this position shown here, and it will again get power into the stop block. Here's a photo of the actual assembly here on the left, and the drawing we've been looking at on the right. You can see I got the terminal blocks to line up the same way. Here's the 6 terminals, 1 up here and 6 down here, corresponding to terminal 1 up here and terminal 6 down here, but I had to rearrange the position of the relay, which is here, and the block signal detector here a little bit versus the drawing, just because of the way the wires come out of these two things to make it wire up as best as possible. If you had somebody build you one of these units, essentially and hand it to you all assembled like this, hopefully neater than what I did, you'd end up with something like this. You'd have a black box here with your 2 input, red and black input wires going into it for power, fixed accessory voltage, and then coming out your 2 output terminals, which would be either connect or disconnect power to the stop block. So considered as a unit, it just has two inputs for power and 2 output wires to connect to the block. In the first demonstrations, we used this red block as a stop block where it completely stopped the train if the block was red. But we can also, what people have also done is they make this into a slowdown block instead of a stop block, and that was shown in the previous demonstration D. And what we can do is add a rheostat between the yellow wire and the white wire, so we've got a rheostat in parallel with these two, with the input and the output. And let's see if we can show that. There's our rheostat. Now what happens if the block, if the detector is in the red state, so that the relay is changed from the normally closed to the open position, and there's no current going through here, or current, and again, think of it as water going through a garden hose. Our current coming up here, it can't go through here anymore because the relay is open and there's no path, but it has an alternate path through this rheostat, which is essentially a variable resistor, which you can adjust to get different speeds through the slowdown block. But now the train, instead of completely stopping in the slowdown block when it's red, it'll slow down to a speed as determined by this rheostat. And then when the block changes back to when the detector changes back to green and this path is available for the current, it'll go through this way because it'll have less resistance. So your water in your garden hose will come up here and go through this way when the block is green. But if the block is at red, it has an alternate path, not as easy, but an alternate path to go through the rheostat, which will give a reduced voltage on the red block here. In the demonstration, I used the same length of block, but if you were going to build it to use, you'd probably, as a slowdown block, you probably would want to make this a bit longer, so you had more distance to slow the train down. And it's always good to do all this on a straight track if the layout makes a straight section long enough available.